Hello, how are you guys today? Hope everybody's doing well. I know it's the end of a long day in Germany and it's midday here in the United States. Today, Wally Pratt and I are going to be giving you a little bit of an overview of HART-IP and how we believe it's the simple, secure, and proven solution for Ethernet-APL. So first of all, the agenda. I'm going to talk a little bit. My name is Paul Sirico. I'm the Director of Marketing and Product Strategy at Fieldcom Group. I'm going to be chatting with you a little bit about just some general technology directions at Fieldcom Group and why we think they're important. Then we're going to talk about Ethernet-APL, which is a kind of a big deal at this particular ACMA show since it's the official launch of the technology. Wally's going to give you an idea on how HART-IP fits into Ethernet-APL, and we've got a little demo that we're gonna try and show as well, and we have a Q&A session that we're going to close this out with during the last 5 minutes. So let's set the stage here. We're going to talk a little bit about 21st century process automation and a few things that are influencing it. One, obviously, is the more open architecture. Two is the IT and OT integration. And third is how does a company like Fieldcom Group help enable those technology needs. This is the very familiar more open architecture slide. And you can see that the more open architecture is designed to do a couple of things. First of all, it's designed to build on top of existing technologies. So let's not muck around with things that already work in the plant. Let's build something alongside it that can help get more of the monitoring and optimization techniques that Namor would like to do for advanced analytics and applications like that. A lot of the stuff that we're going to be talking about today is really going to be probably deployed in this plant-specific MNO area, but that's not to say that HART-IP over Ethernet-APL is not a good fit for control either, but we'll show you that in a little bit. Fieldcom Group is trying to address this 21st century process automation landscape by doing a few things. Up until very recently, this was our technology portfolio. We had HART, wireless HART, Foundation Field Bus, and FDI technology. FDI is a relatively new technology, and it makes devices more accessible to control systems predominantly and asset management systems. It's easy to deploy and and things like that. But there's a need for a common information model and the ability to simplify application development. So there are a lot of initiatives that are going on in the industry to address this. One thing that's going on is the Ethernet-APL initiative. And what Ethernet-APL does, obviously, is it allows for IP-enabled communications all the way from the field device up into your HMIs, your maintenance terminals, your control systems, your asset management systems, what have you. And that eliminates gateways and eliminates eliminates protocol translation, obviously. So, we are all on board with the Ethernet-APL initiative. We're one of the SDOs that's participating in it, and one of our offerings is going to be HART-IP. HART-IP will enable HART-IP, and an IP network in general will enable devices to connect easily into these aforementioned plant systems, but it'll also allow for devices to be connected through an edge gateway to cloud systems and use other types of technology to add, to add even simpler integration. Ultimately, you want to get to the cloud, and HART-IP with a Namor data diode, using our process automation device information model as well, is a great solution for moving data, standard HART data that's being managed by standard HART systems with standard HART applications. You can move that data up into the cloud using a combination of HART-IP, Ethernet-IP, and the PA-DIM information model. Obviously, security is an issue. Security is something that we've addressed very thoroughly in HART. Wally's going to talk to you more about that, but the latest revisions of the HART technology specifications really, address security head-on, and we have a great solution for it. So what that means is that the summary of all of this slide, this kind of busy slide that I just showed you, is that at Fieldcom Group, we have a number of strategic directions, strategic initiatives that we're putting in place. First, industry-wide cybersecurity alignment. We want to make sure that within all the standards organizations, there's a common alignment on security, and we're working with other organizations to do that. We want to make sure that HART is a protocol that can extend into the 21st century, because many of you have made large investments in HART technology. Many of your technicians, if not all of them, are familiar with using HART technology and HART configuration software and diagnostic software and HART-based asset management and control systems. And we also want to be able to extend onto that some of like IT-friendly device data. So that would be an extension to some of the technologies that we're offering, including Process Automation Device Information Model, or PADIM. So this is all about crossing the OT-IT chasm, as we like to call it. And the challenge that I'm sure you are all familiar with in your own facilities is that OT understands automation protocols and field bus and DDs and device drivers and things like that. Plant IT, on the other hand, understands asset management and Ethernet networks and security of those Ethernet networks. And ultimately, enterprise IT understands ERP and analytics and also security, of course. So the challenge is to build a bridge to cross this chasm. Data is lost in translations across systems. Electronically, it's lost because this information does not move through the layers. Semantically, it's lost because information moves, but meaning is misinterpreted. So Ethernet-APL does a great job of addressing many of these problems, but it's important to you as a user to understand whether you're ready for Ethernet-APL. And I like to caution this, because it is a new technology, and yes, it is going to be a big deal. But I think different industries and different organizations are going to be adopting it at a greater or lesser level and in specific applications. For example, I did a survey a couple of years back around the world, various oil and gas national oil companies, mostly in Asia and the Middle East. And we did in-person interviews with 60 oil and gas end users. And what we asked them, I asked them a series of questions about different physical layers and different software models. And, what we found is that there's a vast difference in the willingness to use a technology based on the application that technology is being used for. So in the chart on the left, what this points out is that everybody's willing to use 4 to 20 milliamp HART in safety and regulatory control applications because it's a known technology. They trust it, it's reliable, it works, it's simple, and it's proven. But as you go to some of the more monitoring and optimization, and if you will, NOA information model type applications, monitoring and optimization specifically, there's a lot less reticence to use newer technologies. And this is where we believe that HART-IP over APL or any other protocol over APL, for example, will initially enter the market. This is the same graph shown in a slightly different way. And as you're considering the adoption of Ethernet-APL, I strongly consider that you think about your users. Are your devices primarily used for monitoring and control? Does the speed of 10 megabits work for you? Do you see benefits in it? Are you comfortable with an Ethernet-based field network where every device has an IP address? Are greenfield applications a large part of your future plans? The reason they ask that is if you're putting in a greenfield and it's going to last 30 years, you might want to use the newest technology that's coming out. And what are your internal capabilities? Is your workforce capable of doing this? Are IIoT type activities of interest to your future business? So I'll leave you with those questions for you to ponder while I jump into a discussion of what Ethernet-APL is. I'm going to do this very quickly because Wally's got some great stuff on HART-IP. So first of all, Ethernet-APL, the mantra, 2 wires with power, 10 megabits per second, intrinsically safe. This is a physical layer designed exclusively for the process automation industry. The work on it has been going on since 2015. Here at Acoma Pulse 2021, we are officially launching the technology. I'd encourage you to watch a multi-vendor demonstration of where the technology sits today that I gave earlier in today's sessions. Basically, the technology's launched. We've been working on it since 2015. The specs are available. Some products are in the market. More will be coming out soon. It was developed by a large group of companies, 4 standards development organizations, 12 suppliers. So there's a lot of people that are invested in making Ethernet-APL a reality. It's a compilation of global standards. So we use IEEE standards, 10-base-T1L for the base PHY. We developed our own port profile so that different devices that have different power requirements can be handled in the switches. And we developed our own intrinsic safety requirements so that the instrumentation and the field switches can be deployed in hazardous areas. Oh, and by the way, it uses standard cable that you've been using already in Foundation Field Bus and Profibus PA applications. Few key terms. Advanced physical layer, it's just a 10-base-T1L. Ethernet-APL adds intrinsic safety, adds power profiles. And an Ethernet-APL field device is a product that supports the Ethernet-APL physical layer plus an automation protocol, unless it's a switch, in which case it just supports the physical layer. So it's, again, field communication on 2 wires, and it's 1,000 meters of distance, EX, 10 megabits per second. Fantastic new technology. So, as I mentioned, the Ethernet-APL supports all long cable lengths. You see here that there's a couple of elements of the architecture that are worth discussing. First of all is this APL power switch. And the APL power switch provides power to the field switches, the underlying field switches, and have up to 1,000 meters of trunk length between them. Spurs of up to 200 meters are then where the instruments are connected. They connect into the field switches. And depending on the design of the device, you can go all the way into zone 1, div 1 with this, and it works. So another interesting thing about this is that I'd like to point out is the field switch is just a switch. It's not a proprietary protocol. So in theory, you can hang instrument from multiple automation protocols or standard, or standard IP instruments with no automation protocol off of these switches. So think of the Ethernet-APL network as a network from which your field devices are connected. It'll open up your mind a little bit to the possibilities that are available by using this technology, independent of the automation protocol that you prefer. And it fills a gap. One of the main things that it does is it fills a gap between the field network and the enterprise. And it does that by minimizing all of this protocol, electronic protocol translation. So we're very excited about Ethernet-APL, and that's why we have significant efforts underway to adapt HART-IP technology to Ethernet-APL. And with that, I'd like to turn it over to Wally.
Want to welcome you to the presentation. We'll start with just some brief introductory stuff, and then we'll go into some more of the technical details. HART-IP has actually been around quite a while. It's in some ways it's like HART. It's kind of invisible, doesn't get a lot of press, but it's done a lot of good work. We originally deployed HART-IP in 2009. Back in those times, since it was really a simple augmentation to the standard HART protocol, that was really just a white paper. Since then, we've involved it into a part of our HART standards, and then continued that improvement to, go from you've got to have security to you've got to have this security when we released version 2 of HART-IP in 2020. So what we're going to talk about today is really that next evolution of HART-IP. Generally, HART-IP is kind of a backbone. It's a backbone for HART-enabled communication. It really is physical layer agnostic. It's like any other IP protocol you have out there. I mean, it'll work over cellular networks. It'll work over gigabit Ethernet or Wi-Fi. What we'll talk a lot more about is how it works well with APL, which is an Ethernet physical layer, which IP's worked over Ethernet since the Earth was cooling. HART-IP, just like the rest of the HART protocols, consists of two communication modes. One is a cyclic communication mode. This has been around since about 1990, and it essentially publishes data to data consumers, historians and controllers and what have you, as well as the ad hoc request response communication, which everybody knows because that's what the handhelds use and that's what your plant asset management uses. So again, we're continuing to improve this stuff. We've made improvements to the publishing data, and it's part of this ongoing evolution of the HART protocol. The main point of this is to look at that little red box up there that says HART-IP. HART-IP is a simple wrapper around existing HART packets. At the end of the day, it has a header, and the principal payload is the same 420 milliamp packet that you've been using in HART since the 1990s. So the application doesn't change. It's the same way of conveying data, has the same digital process values and what have you. It's very similar to what was done, for example, with Modbus TCP. So it's really fundamentally a simple idea that we've continued to improve on. There's actually quite a bit of HART-IP equipment out there, again, somewhat invisible. If you look in the upper left, there's HEMA safety PLCs uses HART-IP as its backbone. Honeywell has remote terminal units. If you have wireless HART anywhere in your plant, you've got HART-IP already, and you've been using it for a long time. And the next generation of multiplexers and I/O systems are evolving to HART-IP because HART-IP is a lot simpler than RS-485. And when we looked at the next evolution of HART-IP from just saying you got to have security to really taking a deep dive in security, we took what we learned with the really robust security wireless HART and established the same concept as a multi-layer security with HART-IP that we have experience with elsewhere. And I like to call this the triangle. There's three pieces to this. Okay, first, there's fundamentally very robust digital communication security. This is essentially defending your communications. We also use kind of an IT standard, industry standard concept called syslogging. Syslogging pushes out messages to servers that are in your plant if you choose to use them. They're optional. That logs the significant events that goes on in these devices. Things like, gee, we've got a new client joining the field device. Or, really interesting, somebody changed the configuration of that field device. How about that? So you'll get notice now. Since syslogging is not always there, we also have a diagnostics. This essentially allows us to track what's going on this device. And these audit logs include things like who has talked to your device and when they've talked to it, and whether that person that talked to the device changed that device's configuration. And quite frankly, our experience is one of the things you have to always be cautious with in a plant is, well-intentioned technicians making changes to your device. Well, not only can you know the changes happen, you know when they happened, and you know which tool was used to make that happen. And so this is really, really robust security stuff, really a multi-layer thing. The communication security is based upon TLS and DTLS. These acronyms, transport layer security, these are used in banking applications. So these are really, really robust, well accepted. We're using the pre-shared keys. This it means that you enter a key to start with, very similar to what you do with wireless HART. So we're trying to keep this simple. We're trying to make it work so that it's very well suited for air-gapped network that you don't have connected to the cloud, where you don't have to go to certificate authority someplace on the internet to ensure that you have good security. And so this is really well-intentioned or well-targeted to embedded applications. This is kind of the basic way you get started with a HART-IP device. We're kind of building upon your current experiences of the HART users out there. You get a device out of a box, you enter a tag and a few other things, and then you take it out to the field and install it. Well, we've added a few things to it. You add a unit tag if you want. You enter a pre-shared key in the name of that client. And if you want, you can also include a syslog host name in case you have syslogging installed. So with these few simple things, you now have very robust security. And how do you find the device? Well, we build upon the concepts you already have in your plant. Everybody in plant, totally throughout the plant, thinks in terms of tags for field devices. So the tag that's in this HART-IP device becomes the host name, which you find with your domain name servers. And in fact, HART-IP devices have been using the tag as a host name for over 10 years. And what that means is your control system knows the tag of what it's talking to. Your technicians know the device tags. So we're building upon this metaphor that you already have. And to bootstrap it up, we have introduced the concept of factory reset, which gives you one try only to get your security up and running. So the actual initial commissioning is also very robust. It has same application layer as HART. I'm going to skip through this pretty quick. Use the same digital data, use the same HART tools, build on what you already know in HART. A lot of systems today have HART digital data permeated throughout those systems. And so those guys is simply adding a new IO card to get you up and running with HART-IP because you're already using it.
Looks like it's time for the demo.
Okay, go to the demo.
Ethernet-APL is a new technology that is going to transform our industry. It describes the physical layer that many digital protocols can share in a plant's field device network. In this example, we're showing the HART-IP protocol, which is a secure protocol communicating from this digital valve controller and this level transmitter to an electronic marshaling subsystem and onto the controller. It's also sharing that same electronic marshaling platform can aggregate other signals such as this traditional 4 to 20 analog temperature transmitter and this level transmitter, which are also HART devices, showing that even though we have a brand new technology, you don't have to retrain all your users of the solution on any new protocol or new tools. They can all share the same HART platform.
HART-IP over Ethernet-APL is capable of control. This demo shows a PID control loop with an APL level transmitter and the APL digital valve controller. For demonstration, we can move the set point and observe the change in the control output. Ease of use is another important factor, and familiar tools for device configuration, calibration, and troubleshooting will facilitate the transition to Ethernet-APL. We can observe how the same configuration tools can be used for both 4 to 20 milliamp devices and Ethernet-APL devices. These tools are well known by the instrument techs around the world. The user experience for HART devices is the same for both 4 to 20 HART and HART-IP over Ethernet-APL. Same protocol, just different physical media. All advanced diagnostic tools are available over Ethernet-APL. Here, we show an example, the Radar Master application for guided wave radar level transmitters.
As the use of Ethernet devices is expanded to the field network, security will be critical. The latest standard of HART-IP includes all the elements required to secure the communications between the field instrumentation and the control system and the asset management solutions that will be provided by the vendors. This demo shows communications from the level transmitter securely to the controller and then securely back to the valve, preventing any sort of tampering in that communications and ensuring that this closed loop control demo comes off without hitch.
So that was really a great presentation. I really appreciate the effort going into that. So let's do a few things to wrap up. One thing I want to point out is that in the day of streaming videos and 10 gigabit data, I want to point out that especially for process automation, 10 megabits per second is really fast. We've done our numbers. I'm kind of a geek, so I'm a numbers guy. And so we went out and said, all right, worst case, if you're really using the HART-IP a lot and you're trying to saturate the network, what happens if you're really successful in that regard? First off, we assumed a very small portion of the bandwidth. Fundamental to the way the HART attitude is in our groups is we want to have great coexistence. We want to be a good neighbor. We're not going to be a pig. So assuming a small portion of the available bandwidth, how many devices can we get running 25 updates per second? Magic number is 117 devices. That's a lot of devices on one pair of wires. Okay, and that's really twice as many devices as the APL physics even allow. So one of the things we want to assure is that, especially for process automation, there's a lot of throughput available here. And that gives you room for both monitoring, optimization, and control because it's all there. HART has evolved, not only that, to be very efficient. We're now focused from just publishing data to publishing by exception. And what that means is that we should provide you the information you need, not just flood the network. And so we can do things like set up a window that if the process is not changing, we don't send you anything new. And, you know, really with HART-IP, we're ready for this convergence, the growth of measurement and optimization, plus HART-IP, plus Ethernet-APL provides a lot of opportunities for everybody.
Thanks, Wally. That's great. We have exactly a minute and a half left, I think. And if there's anybody out there who has any questions, please shoot one at us, and we'll give it a couple minutes for somebody to type a question. If we don't have any questions, the assumption that is that everything was crystal clear and you completely understood all that we said, and you're going to be working with HART-IP over Ethernet-APL in the future. So, and we look forward to helping you do that. Okay, doesn't look like there's any questions, so I think we're all set. Thank you very much for attending this session. It will be recorded. And Wally, do you have any closing comments?
Hey, let us know how we can help. That's what PhilComm Group's here to do, is help you be successful.